Hello, in this video we are going to learn about the model we are going to use to represent the machine we are going to be executing our algorithms. In the rest of the course we are going to use this model to analyze our algorithms. The model is called the random access machine, and as any model is a simplified representation of reality. So our reality is a computer. A computer is a complex creature, so you really don't want to deal with all the details inside a computer. Instead, you develop a model that is simple enough to get to analyze what you want. So we can choose a model that is so complicated like this, but it's not going to make us any favor doing this sort of model, such a complicated model. And we can start abstracting things and get simpler and simpler models until we get a model it's really useful for us. In this course, this model is going to be good enough for us. So we have a central processing unit that can read and write data from the external environment. You can see it, you cannot see it here, but here on top of output it says input. And this central processing unit also has access to a storage and where it can write and read data. So based on this very simple model, to estimate the time of an algorithm, we are going to follow 4 assumptions. First, we have a machine with a single processor, which means that we have sequential execution of instructions, not concurrent execution. Second, each simple operation takes 1 unit of time. And what are the simple operations? First, numerical operations, subtraction, sum, multiplication, etc. Notice here how this is a really simplification of the reality, because you know that a multiplication is made of several sums. So in reality, it's not possible that a multiplication takes the same time as a sum, unless you are multiplying by 1. In this model, we are going to assume that every numerical operation takes 1 unit of time. You will see in due course why this is so. And the control instructions as conditional branching, calling a function, not executing the function itself, but just calling it, and returning a value, take returning from a function, take just 1 time unit. Third, loops and functions are not simple operations. They really take longer. So when you face a loop or a function, a call in your algorithm, you have to go inside them and see how many simple operations they are made of. Fourth and last, memory is unlimited. We don't have memory constraints in this machine. We also do not have memory hierarchy. Usually in a real computer, data that is in the cache memory is accessed much faster than data that is in the RAM memory, and this data in turn is accessed much faster than data that is in the hard disk. In this machine, in this model, we are going to assume only 1 storage unit, and every access either to write or read data is going to take 1 unit of time as well. So with these 4 rules, we are going to analyze a very simple algorithm just to see whether you are following me. So this is the algorithm we are using, and let's look at the first instruction. This is a memory access. We are writing a number 2 in memory, okay? And if we go to rule number 4, we know that memory accesses take 1 time unit. So here we have 1 time unit. The second instruction is exactly the same. Oh, a loop. Loops are not so nice, are not simple operations, so we have to dive into the loop. Let's see what happens here. This is a while loop and we are checking a condition. So actually what we are having is like having a if. And if are simple operations according to this model. So we are checking whether I is lower than 3. Let's see how many times we have to do that. So we have to check the first time when I takes the value 1. We enter the loop, do the iteration, and then I takes the value 3. Go back to the checking and we check for a second time. 3 is actually lower than or equal to 3, so we go inside the iteration. Now I takes the value 5. We go back and we check whether 5 is lower than 3. Third checking. So we are checking this condition 3 times. And because checking a condition takes just one time unit according to the model, because the if is a single operation, we are checking one time unit 3 times. Let's go inside the loop. Inside the loop, we have 2 instructions. This instruction takes first one numerical operation here, that's one time unit. And then we have one written from memory, one time unit, so we are 2 now. And then after we have done the numerical operation, we have to write in memory. So we have 3 time units to perform this instruction. So this is the 3 that you have here. But this instruction is executed twice. In the first iteration, I takes the value 1, first iteration, then I takes the value 3, second iteration, then I takes the value 5, no more iterations. So this instruction that takes 3 time units in this model is executed twice. That's why we have a 2 here. Exactly the same with the next one, and then we have a return. The return, you can also argue that it takes 2 because you have the return that takes 1, and then you have to go to memory and retrieve the value of x, and then it might be 2. Either of those, it's a valid calculation. You will see in further videos why this is so. So according to this, we have 1, 2, 5 plus 6, 11 plus 6, 17 plus 1, 18 time units to execute this algorithm. Let's see what happens with the space. The run model for space is really simple. Every single variable, irrespective of their type, takes 1 space unit. That's it. That means if you have an array of size n, then you need n space units. So if we analyze exactly the same algorithm in terms of space, what we have here, we are creating a new variable. So we are going to require 1 space unit here. We are creating a second variable, I. So we need another space, another memory space. And then we are not creating new variables. So in summary, this algorithm requires just 2 space units. So this is the summary of the run model. Whenever you analyze an algorithm, stick to these 4 simple rules for time and to this simple rule for space, and make sure that you dive inside loops and functions, and you will get the estimation of the time and space your algorithm takes. In the next video, we will get into more details about this.